To sense the current, rather than putting the meter in series with the current path, I've added a 10 ohm resistor in series with the meter because it's up on the panel and easier to access. So I can simply measure the voltage across this to get the current. Here I've got the meter connected across the sense resistor, and it's measuring on the milliohm scale, and when I fire the laser it reads correctly. So that's reading 10 milliamps there, and we're dividing it by 10, and the meter on the front panel is reading 10 milliamps as well. So that shows it's working correctly. Here's a quick high voltage divider I made up. It consists of 10 47 mega ohm resistors in series, and at the end is a 1k resistor to act as the bottom resistor of the divider. And I'll put it all into a plastic tube just to give something to hold on to as a sort of probe. You can probe the other end with things. So I've enclosed the resistor divider in a plastic tube for protection. One end is just the pin coming out the resistor, and the other end is the two wires off the lower divider. So I'm currently applying 400 volts across the whole thing from my little power supply. And if we look at the divided voltage, we get millivolt scale about 0.87 millivolts. So from that we can work out the division ratio. Here's the measurement setup for looking at the voltage and current through the laser tube. I've got 2 meters. The one on the left will measure the tube current, and the one on the right will measure the tube voltage. So the tube current is being measured by the voltage across this 10 ohm current sense resistor placed in series with the tube, and that's being measured by my relatively new fancy meter. The tube voltage is measured by the divider, and it's connected to my cheaper standard meter just in case something goes wrong and the meter gets fried by the high voltage. The divider tip will be touched to the tube anode. I've cut away some of the insulation so you can see the bare metal there. So that's going to be touched just like that. The negative return of the divider here goes to see down there, the bottom end of the tube. That's the bottom of the 4 terminal connections. So we should be ready to give it a whirl. Okay, so I'll turn the laser on, and put the power setting to maybe 20% power, just something to try. Now, if I've got enough fingers here, I have to press both of these at the same time for it to work. There. So, pressing these, you can see the current meter reads 3.8 milliamps, and if I can perch this somewhere, maybe there. Okay, I'm going to touch the probe to the high voltage terminal and turn it on again. Just a minute. Okay. 22 millivolts. Now there is actually quite a large AC component present in these signals, but I'll just measure the DC value for now. So let's work out what that actually is. Remember it was 3.8 milliamps. Remember the divider is at 460,000 times division. So it's, what did I say, 22 millivolts times 460,000, which is about 10 kilovolts at 4 milliamps, which is about 40 watts going into the tube, which seems about right. So I'll repeat this for some other power settings on the knob and see what values I get.